So, good afternoon, everyone in the audience, dear colleagues. It's a great pleasure to have you here at a side event of the One conference. And I would like to take the opportunity, first of all, to thank EFSA for giving us the opportunity to present here a specific idea and a specific project that we pursue for quite some time now jointly with EFSA. And the overall topic is about towards interoperable One Health model repositories. And if you have followed the program of this conference, you have heard about this problem in every presentation, more or less, that we need to improve how we share knowledge, especially if it comes to the One Health context. So this workshop, this side event, is about one potential solution. So not only addressing the question that what we have to do, but also to tell you how we can actually approach it. So to present you our ideas and our solutions, we have a small program now, 1 hour. We have to be strict with the time because the next sessions here will start at 2 p.m. already. So after first this short introduction, you will hear from my dear colleagues and friends about the RACIP initiative and about the solutions. So let me first introduce to you the speakers of today. So we have Martin Nauter, who works now at the SSI as a researcher. We have a presentation from myself. After that, Martin Luong will present a live demo of the model repository that we have established. He works currently as a postdoc researcher at ANSYS. And we also have Didier Velot from EFSA here, who presents the view on EFSA on this and how this integrates in EFSA's strategy. But before we start with the official program, I would also like to take the opportunity to thank those people who made this event happen, and especially my colleagues Yvonne Mensching and Estival Lopez de Apochuco, who really worked hard in the back to implement all that and to organize it. And of course, the staff here on site. So just one last housekeeping comment. If you want to ask questions, we have a question and answer session at the end. So please use the One app. You're familiar with that. And we will address the questions afterwards. And if you have complaints, you have the name of the chairperson there, so then you know where to whom to address that. So with that, I want to hand over now to Martin and wish you a pleasant event. Thanks.
Thanks, Matthias. I hope my slides come up, but I guess they do. Yes. Okay. So what I will do is I will first shortly say a few words about RACIP, about the project, what we've done so far, and what our vision is in general. So let me start with that. Yes. So, well, the whole idea of doing this, of starting the project, it started with a type of frustration that you probably know. You have something, a very nice piece of equipment, a nice tool, and then you want to use it and you get in another environment than you used to, and you have a struggle, you can't, because it doesn't fit. Yeah? What happened in something like that, it happens frequently in life, but it can also happen when you have a model. It can happen when you have had a nice project maybe a European project, you had to have developed a software tool. After the project, other people want to use it, but it doesn't fit with other objectives, and it can be forgotten. And that can be extremely frustrating, both for the people who made it and for people who want to use it. So, what's the solution? We have to come up with something that translates different models, translates different tools, and for that purpose we have the RAKIP initiative. So, what is RAKIP? Well, RAKIP started as an initiative between 3 institutes, ANSES, BFR, and DTU Food from Denmark. By that time, I was at DTU Food. We dealt with this struggle that, well, there are many risk assessment models available. They are developed, but they are not used. And that's a problem in many ways, because it's a waste of energy. Well, people want to use it, but it's just too much of a struggle. And what is needed is, well, the tools should be able to communicate. You need to have a similar terminology, for example. Yeah, that's one reason why it can be hard to exchange things. And that's also something we see in a broader perspective within One Health, of course, that terminology can already be a big challenge. So, what we wanted to do is to facilitate the reuse of food safety risk assessment data and models, and also by that facilitating doing quicker risk assessments of high quality. The focus of the project initially was on microbiological food safety. We're now trying to extend it all over the One Health area, you can say, and maybe even beyond. So the first thing you need when you want to exchange models is to have a repository of the model. So you should know what's available. Yeah? So for that purpose, we built the RAKIP model repository. You see here that it has several qualities. You can search models, you can select models, you can look for all the details of the models. The metadata of the models is stored, so everything behind it, you can find all the references, etc. And you have also the possibility to run the models. So that's the ideal situation that we want to do, is to collect as many models as possible in this repository. And we started by building up the repository and start filling it. Yes. So how does it work? Well, we have this RAKIP. Where am I? Here. The model repository, it contains different models. Who can use it? Well, it's both useful for modelers, so people who are into making the models, the more mathematically inclined people. Risk assessors, risk managers can look into, they can run the model, you can see what the model is doing. The modelers can create models, share models, improve models, and also other scientists, well, they can share their data, the data can be also then be put into the models, etc. Yeah? So it's there to be used by end users with different purposes. Well, to make these models speak with each other, you need a language. And, well, it's Matthias Fielder at BFR with his team who have been working hard on developing this exchange format. We call it FSKX, which stands for Food Safety Knowledge Exchange. You can see it's a new file format, you can say, in which you can store your models. And you can look at it as the English of the models. Like you understand me here all because I talk English. Yeah? If I would talk my mother tongue, then probably most of you wouldn't understand it. But fortunately, we've invented this language so that we can exchange things. This is the same story. Within this FSKX file, you can basically find all the information. You have the input data of the model, you have the metadata, so everything around it. The software code is there, and also the outputs. You can see what's coming out. To work with it, there's a specific tool called FSK Lab, which allows you to run models, to modify models, to combine models, create models, etc. you can get nice workflows like you see here. Yeah? So the tools for doing it are available thanks to this FSKX files and FSK Lab. Well, just a few words about the whole project. Well, we started, the idea came in 2016. Matthias and I discussed the other night how exactly it happened. We didn't completely agree. But anyway, it was sort of a meeting like this, where you meet people, you start talking about, hey, can we start up something like this? Well, we managed to start it. In the first years, we spent a lot of time on talking about this harmonization of terminology and concepts, developing the ideas for how to develop all this. Then in later years, we started filling the repository. We have organized workshops like this in different conferences, both related to predictive modeling in food and One Health. We strengthened the infrastructure, and we were very, very happy that at some point EFSA was also interested and decided to join us. There has been made a connection with the EFSA Knowledge Junction, which of course contains a lot of models. You may know that. So EFSA joined also last year, and that is a sort of beginning of what we see as an exponential growth of the project. We hope that more institutes will join us. We want to expand a bit from only microbial risk assessments to the One Health domain in a larger extent, because many of the principles are similar also when you go over more disciplines. And we hope that with more partners we get more impact. You see here, this is the first logo we had. We just changed it into this one because we are growing. Well, also we've had several publications. I just show a few of them here. So you can find more about FSKX and the RAKIP project and things around it in the literature. If you want to start with some, oh, no, I do the wrong button. If you want to start with something, you could look into a current opinion of food science. Recently, we published an overview paper of what the model entails, and now all sort of strange things happen, and I'm not doing anything. And now nothing happens. Yeah, okay. So my last slide. I want to invite you to plug in and join us. We now have, you see, we started with 3 institutes. We now have 6 of them. And we are open for more. And with that, I want to thank you for your attention.
Thank you, Martin. I will follow up on that. And I give you a little bit more deeper insight into some of the solutions that Martin already mentioned. And at some point, exactly, this is my little presentation here. It talks a little bit more about this FSKX format, because in the end, that's the key enabler here to solve the problem of information exchange. This slide is my favorite slide if I want to illustrate the challenge that we actually face right now. And again, I have heard the problem description over and over again in these days, that we need to collect information about all the different entities that we have to consider in a risk assessment or for decision support. So may it be the hazard, may it be the population, or may it be the food. So data gathering is one essential task that we have to do. But then on the other hand side, we also need the infrastructure, right? And this starts with the analytical methods. It goes over to the statistical methods, and finally simply to the IT system. So it's clear to everyone that big data cannot be handled on a laptop anymore. And often enough, we struggle with the situation that the analytical devices produce data that we where we need 10 years to understand how we actually make sense out of that, because there are too much to also from a statistical point of view. It's challenging to really evaluate all the data that we get. And then, of course, on top, we have the problem that the world is changing. So data that might be true for the last 10 years cannot be used to predict the future anymore because the environment changed. So, and all that has to be integrated into our risk assessments. So I think that slide summarizes that problem. And as I said, this also leads to the fact that for decision support in these days, we use more and more mathematical models. And we had here at the conference also a session on AI systems. I mean, this is just another level of modeling. And we already use these models in our daily life already. Yeah? So here you see a number of model types that are applied along the farm to fork chain. And of course, there are more model types around. And this figure also illustrates nicely that it would be really nice also to plug and play models from different disciplines into each other. So the output of a animal disease model might be relevant for a food model or for an exposure model. The same is true if we have dose response models. We, of course, want to use this also in conjunction with population models. So the problem is clear, and now the question is, how can we do something about it? But before I explain it in a little bit more detail, I also want to point to another challenge that we have. Often enough, our models are made available in formats that are not interoperable. So you publish your model in a scientific paper. If you are lucky, you find the source code attached to the paper, but there is no way how you can actually execute the model in the journal. Yeah? So it's completely impossible. And if you want to use the attached source code on your local computer, you suddenly have a problem because you don't find the libraries anymore that were used in the model. You suddenly see parameters not described in the paper that you cannot interpret anymore. So all these kind of issues you are for sure all familiar with. So and then of course models come into different programming languages. So and you might also want to use models that are 10 years old. Yeah, so it's not only that we can say now to everyone, use the programming language R for your models, and we have the problem solved. That's not possible. We also have to keep in mind that we have a legacy, and we have to use the existing knowledge for the future. So the only solution that is possible, in our opinion, is that we have to create this exchange format for models. And this exchange format must be flexible enough to address all these languages. So you probably know that in other scientific disciplines, these exchange formats already exist. For example, in systems biology, they have standards, how models should be described. But these standards often enough require software-independent representation of the model. And this, of course, doesn't work. So I cannot ask anyone to reprogram his 10-year-old model into a software-independent representation. No one has the time for that. So the only solution is that we create an exchange format that is capable of taking the R code, taking the Python code as it is, and just create a wrapper around it. The wrapper contains all the meta information, and we then consider, so to say, the model as a kind of black box. Yeah, we just describe what goes into the model, what comes out of the model, and what is the model good for. Yeah? And with that kind of information, we are able to exchange models, and then it's a task for the software developers that provide solutions to create solutions that are capable of executing an R model together with a Python model and with a Java model. Yeah? But these are technical problems, and these technical problems can be solved. So one point here on this one conceptual point on the slide I want to highlight as well. If we adopt this idea of creating this exchange format for models, and we allow people to share their models in different repositories, then these repositories can also be sourced by software tools to extend their capabilities. Because this is, of course, another question. People are used to their favorite tool, and they don't want to use a new tool just because there's a new model in there. Yeah? But with this exchange format, it's possible now for all the existing tools to create simply an import function for new knowledge that is out there. And in this way, they enhance their own capabilities. Yeah? And for the modelers, the big advantage is he don't have to worry anymore to write a UI for his model, yeah? where any user can provide input parameters for his model. So the modeler benefits and also the legacy tools that we have already benefit from this concept, in our opinion. So now I talked about this wrapper, about the metadata that we put around the model. So this is, of course, again, the challenging task to agree in a community what are the relevant meta information that we want to provide. So and this is work that we had done in RACEP. Yeah? So in the first years we sat together and discussed all of these metadata concepts that we actually included. And we call it now the generic metadata schema. It has a hierarchical structure. It has 4 high-level domains. So, for example, the general information contains information about who created the file, yeah? What license does the file has? What is the last modified date? All these basic metadata that you are used to provide to files. But then there comes this second topic, which is the scope. So this is more the scientific question. So what is this model good for? And of course, this is sometimes hard to use with a controlled vocabulary. So, but here you can provide free text. You can explain what your model is good for. But what you can see here, we already give some advice what metadata might be useful to provide. Yeah? So you might want to describe the population that the model is good for, or the hazard. Yeah? And this goes even one more level down. So if you want to describe the population, then you can say, okay, what describes the gender, if this is relevant, or the age group, if it's relevant. Yeah? So we made really our mind on what meta information would be good to share. Of course, we had this microbial risk assessment in our mind, but the nice thing is that we are able to extend this schema. We can create for each specific model class, like, for example, dose-response model. We can adapt the schema to this model class, and we can say, okay, for the dose-response model, the matrix is not relevant. So we simply skip the metadata fields for this that we have attached to the matrix, and for dose-response model, the people only provide relevant information, right? So, and this is also the reason why we think this format can be adopted to other domains, yeah, because it's flexible enough. And this is how it actually looks like. So you have a zip folder. If you receive an FSKX file, you actually have a zip folder. It has a suffix FSKX. And then inside you find more or less the information on 3 topics. So one, of course, the model itself. It comes as an R code or whatever code. You can even provide the raw data if you want. And you can even provide the linked libraries that you source in your code. Then we have a second area which addresses simulations that you do with the model. So you can actually predefine and name simulations that you have done with this model. Yeah? And you store this information in a harmonized format inside, and you can even store the results. So what you have calculated with your model becomes reproducible by someone else, And if someone else wants to do his own simulation, well, he is free to do. But he can store also his results into an FSKX file. So results from prediction results done by models can be shared in this way as well. And then, of course, you have some other files that you can share, like the publication, if the license allows you to, or data, whatever. So we think this is quite flexible enough. And now, of course, nobody really wants to look into this zip folder. Yeah, so you want to have a nice tool that does the job for you and gives you the relevant information that you are interested in. And it's clear to us. So we said it's not enough to advocate a new format. You have to provide solutions. So the solutions that we now have has been mentioned already. It's the FSK Lab software. I bring up another slide on that one. We also have already a library that's called FSK2R, where we have started to provide support within the R scripting language for FSKX. Then we have these model repositories, and one of them will be illustrated also by Ndu in the following talk, where he showcases you how the functionalities are of the RACAP web model repositories. But as I said, it's no need that we only have one repository. We can have multiple ones, and there are already multiple ones. For example, the Knowledge Junction from EFSA, but also we have certain virtual research environments where models are available and can be shared. And finally, we also have journals that actually adopt this idea. And the nice thing with this journal that I promote here is this is actually an executable model journal. So what you can do is, and I will bring up one slide on that as well, you can actually upload your FSKX file into the journal. The journal extracts all the metadata, puts it into the right place of your article. You do some text massaging then in the article. But the nice thing is, once the article is published, you can actually execute the model directly from the journal article. Yeah? And this is, I think, a cool feature. Okay, so now a few slides on the different solutions we have. So I pointed explicitly out here what we think is the most the target group for that. Yeah, so I think the software FSK Lab, which runs on your notebook, this is something for the modeler for sure. Yeah, so people who want to use FSKX files, want to combine them, want to modify them, modify the code. That's all possible with this graphical programming tool KNIME and the extension that we created for that. So you see here on this on the left-hand side, you see the so-called nodes, so small functional building blocks that we created in the software. And what you actually do is you create from these building blocks then these workflows. Yeah, and you can actually combine it as you need. Yeah, so for example, here in the upper workflow, you see two nodes that read in an FSKX file. Then they connect the node to a joiner, and that does exactly what it says. It joins the two models graphically. You can run the model afterwards, and finally you write it out to an FSKX file again. And but if you want, you can actually do it a slightly different way. Yeah? So you have here the runner directly after you read it in each file. And then here, for example, you have the editor node that allows you to edit the metadata of the model. Because if you join a model, you should edit the metadata because it's now a new model. Yeah? So this toolbox is I think, quite flexible due to this modular design. And of course, you can combine it with thousands of other nodes that are available in the KNIME framework. The other thing is this executable model paper journal. And I mentioned already the feature that actually once you provide this FSKX file in your in the editor view of this journal, it takes already all the metadata that you have and put it into the right place. And then you are much more efficient when you write a paper about your model. Finally, this is the screenshot again of our model repository, but I don't talk about that now because that comes in a second. And just a few words about our development plans, because I think that's probably most interesting now for you to hear where is our journey going and maybe whether it is interesting for you to join. So the first thing is we want to extend the format into a linked model and service format. So right now, we share files. Yeah, so you can send it via email or you can download it from somewhere. But of course, in the future, we want to adopt this linked data paradigm where we actually facilitate the machine-to-machine communication. Yeah? So that means we have to go on another level with our annotation of the model. It must support ontologies. And then, of course, we also have to provide APIs so that the machine can actually communicate to each other. The second thing is, of course, software support. It's not enough to create a new software that's supported. We also have to work with other developers that have their systems so that they are enabled to include import and export functionalities. So we are working hard to provide some kind of helper libraries directly from our standard. But we are also working already with some groups that are interested in taking up the FSKX idea, for example, like microhybro. Finally, of course, the most convincing argument if we have a lot of content. So that's something that we are continue to do. All the models that we are working with, we promote the adoption of the FSKX standard, and we are also willing to provide support because it's clear to us that if you have your model ready, yeah, and you are just about to publish it, it's an extra workload for you to convert it into FSKX. We are convinced that you get additional values from that work, but we are also aware that this needs support, and we are willing to provide that to you. And this support can be, for example, that we do trainings, but we will also do one-to-one support. So with that, I don't want to miss the opportunity to thank all the people that supported that. So this is really already quite a long list over these 6 years or 5 years that we are working on that now. And I can tell you that the idea is taken up by a number of different communities already. So I hope that we can really create a long-lasting solution for the domain. So with that, thank you for your interest and attention.
Thank you, Matthias. Sorry. Hello, everyone. So thank you, Matthias. I will spend the next 10 minutes to show you some basic features of the web model repository. So here we are. Maybe I will put on full screen. So we are here in the landing page of the web model repository of Rekeep. So as you can see here, we have the list of all the models which are available already on the repository. So currently we have in total 49 models, but that will be updated by Rekeep member over time. And we have the list of the model, and for each model we have different information. For example, the name of the model, the software that was used to implement the model, the environments for the food products, for example, the different hazards, the different type of model, for example, QRA model, predictive model, the execution time, and also the upload date of the model. As you can see here, we have the different feature. For example, if we want to look, if we want to search for a specific model, for example, model which could be used for listeria, we can use the third feature that you can see here. So the filter features give us a lot of model which is available for Listeria monocytogenes, for example. We also can use the order tab to search for different hazard or different environment. And as you can see here, for each model, I would like today to show you the three main basic features of the repository. So as you can see here, for each model, we have three buttons here. So the first one with this eye logo, I don't know if you can see the eye, but if you click on this, we can find here the metadata under the information, the metadata, which follows the generic metadata schema. So you can find here the general information of the model, the name, the source identifier, etc., the scope, and we can find the different sections, so the type of hazard, the model mat, the different parameters, as you can see here, the plot that can be provided by the repository for this model. We also can find the code, the script R for this model, etc., and also the README section to have a lot of information about this model. So the same thing for all the models. And the second one, the second features that I want to show you is the simulation one. It's very interesting. For example, we can choose a very simple model. For example, here, a primary model to predict the growth of Listeria under the different environmental conditions, for example, in meat product. So here we go for the simulation. So you are here the user interface to perform by yourself the simulation. So each model was implemented with a scenario, as we call this default scenario, the default situation. For example, here the model gives us the prediction of Listeria under the different conditions. For example, temperature at 4 degrees by default, at pH at 6.2, for example. But the interesting point that you can change these values as it's up to you to change this value to create by yourself your own scenario. And for that, we just have to click on this button. So we can add a new simulation here. And to create new simulation, for example, we can give a name for the simulation, my simulation, for example. And maybe we can try to increase the temperature. For example, we can put it at, for example, 20 degrees instead of 4 degrees. And that's it. We can try for this situation. So we expect to have a quicker growth of Listeria at 20 degrees instead of 4 degrees. So to perform the simulation, here we go. I hope the internet works well. Normally it can be quick, but the execution time may be more or less long depending on the complexity of the model that you choose. So for this model, I think that will be quite fast. So here we are. So as you can see here, at the end of this simulation, we have the READKeep web report, so all the results that we obtain after the simulation. So this is my situation, my scenario. So we set the temperature at 20 degrees, and if we compare with the default simulation that was implemented by the model, we can see that the growth of Listeria was very faster, quicker, and earlier if we compare to the default simulation at 4 degrees at temperature. And the next point that we can also download the generate data generated by the simulation, for example, as Excel files. And And here we have the summary of all the parameters values that we set for the simulation. And so on, you can do your simulation with all the parameters value that you wish. And the last thing that I would show you, the last one of the basic features of the web repository is the download button. So with this button, you can download the FSKX associated with this model, and to open this file, we have just to unzip the file. Didn't work. So here we are. So you can find a different subfile associated with the model. So I would like to end my presentation with the point that thanks to the FSKX file, we can easily share the model. We can adapt this model to other situations. We don't have the time to show you all the features of the web model, but we can also create new model. We can choose different model thanks to the different solutions that were presented by Matthias. So thank you all. That's all for my part. Thank you.
Thank you very much. I will try to dive a bit deeper into what the EFSA strategy is bringing us and how this translates in what we are doing here today also and what it means for us also in EFSA. And then just a quick view on our model landscape in EFSA and how it connects then to the RACIP. So I will change the slides myself. Okay. So if you look in the strategy, then you will see in letters like this, and I will quote from the strategy because I don't want to make the mistake run the risk that I make a mistake to quote our strategy wrongly. So that EFSA will ensure preparedness for future risk analysis needs by co-producing and making available knowledge, expertise, methodologies, and data. And this done in partnership with the member states organizations, and also with other EU agencies, and in cooperation then with third country non-EU risk assessment organizations or organizations in general. So we see this partnership also based on trust and shared values as the most promising leverage really to create an EU food safety knowledge ecosystem, we call it in our strategy, but let's call it a community to deliver relevant scientific advice also in the future. Now, what is this partnership? Because we don't use this as a synonym for collaboration. So partnership is a form of structured collaboration, although less formal than a set of delegated responsibilities. It's based on win-wins. It's based on having a common agenda. It's based on doing things together because there's an advantage of doing it together, which really links to the strategies of all people involved. And in that sense, EFSA's joining also the RACIP initiative is really, it's a no-brainer. It was really fitting completely in this partnership thinking. But if we dive a bit deeper into the EFSA strategy also, we have this expected outcome, which is listed there in 2.1.5, that wider access to and a broader exploitation of data and analytics is achieved. And there are some concrete action points linked with this, which are listed there, and I'm not going to really read through them, but if you go through it and you would make the mental check-the-box exercise of everything what has been said here today and what is written there, so that it's straightforward. It fits completely in the EFSA strategy. What RACIP is doing, it fits completely that we would join this initiative because it's a common way forward. So how does now Rakip fit in the wider EFSA model context? And there, wrong side, yeah. And there we already, I mean, it has been also already mentioned by Maarten a couple of times. Also, you, Matthias, talked about the knowledge junction. So for us, it was very important when we joined the Rakip initiative also that there was this link made with what we have, this repository, which is called the Knowledge Junction, which is an open access repository where we put materials linked to our risk assessment. Could be model code, could be data sets, it could be protocols of the risk assessment, could be anything, in fact. The aim is really that we put there the material linked to our risk assessments, and by putting it in this platform, it automatically receives a digital object identifier so that it is really traceable directly and has an own identity. In that sense, that our risk assessments can then be models that are used in our risk assessment, data that are used in our risk assessment can be linked then immediately to what is available there in the knowledge junction. And then the knowledge junction has then for specific models also a link with Rakip for the models which are executable also through the knowledge junction in the Rakip environment. This aim of connecting everything is not only, of course, sharing is extremely important, but the aim is really also transparency for us, because we want to be able, and we are not yet able to do this yet, but in a very nearby future, like it is now, we have to look at a final risk assessment, and there it is really written down there. All the information is given, what has been used, what really has been feeding into this risk assessment in terms of models, in terms of data, in terms of open calls for data, for example, in terms of specific projects that were executed to feed into this risk assessment. Now, in terms of guidance documents also, that methods that were used in general. So this is like it is. So we have to go back. And then you also, by using the knowledge junction, by joining with Rakip, we know where to find those models. What is not yet possible is that, and there we want to go in the future, in the very near future, that if you would pick out a data set, that you immediately then knows which risk assessment would be linked with this data set. Which, if you would pick out the guidance document, that you would know, look, this guidance document has been used for this specific risk assessments. If you would pick out a paper somewhere that you know, look, we know this, it has been used in those different kind of risk assessment, it had this kind of impact on the risk assessment, and so on. So this interconnection is extremely important for us, and we are building here the basis for this. So a lot of discussion still on ontologies and so on, but that's really our main aim, that we are moving this forward. And what we are doing there with Rakip also plays a very important role in this. And hereby, with this, I would like to stop. Thank you.
Thank you very much. So thank you very much for these nice presentations. I see from the chat that there has been already some questions. I can imagine that these questions also are interesting for you. So Constantine Richard Stéphanou asked, is it necessary to have a user account to access the models or to execute the models? So you have seen from the live demo of Ndu that at some point he had to enter his credentials, which were already stored, of course. So the point is the following. When there's a landing page with a model repository where you see all the models, this is openly accessible. So everyone can go there without any user registration, look at the models and download the models. So these are all freely available. If you want to execute the model, then this comes, of course, with a price, because someone has to pay the server. Someone wants to be sure that you don't do bad things with the server. So for that reason, we require registration to use this advanced feature, so to say. But in principle, you can do all the same things also locally on your computer because you have the file. Yeah? So you just need to find the tool or use the tool that does it on your computer. So now the question, how do you get this user account? So I have here already the important email address. So if you're interested in that, send us an email and we will create an account for you, and then you can use this service as well. Linked to that is also the question, of course, where do the models come from? So are you, with a user account, then allowed to add a new model to the repository? So here we have a little bit more strict agreement. So we have a curation strategy established. That means for now, only members of the RACIP initiative are allowed to share their models via this platform. I mentioned already that there are other platforms out there. If you want to share your model, for example, on Zenodo, you can do that there. You can go to a VRE and share your model there. The RACIP repository is for now a repository where, let's say, models with a higher level of confidence are shared, so that these models come from RACIP members. So the other question that I see in the chat is, how about versioning of the models? So it's, of course, also a very highly relevant question. And that's exactly one reason why we joined forces here with the EFSA Knowledge Junction, because this functionality is already available there. So each model that goes to the Knowledge Junction gets a DOI, and there we have the versioning feature, so we don't need to implement this again. So I would say for all the models that we will have also on the Knowledge Junction, we have this versioning feature, but we don't have a notification feature right now. Yeah, so it's of course hard for us to notify anonymous users of the portal. So further questions? I think that were all the questions that I see in the chat. So maybe now there are some questions here in the auditorium. Yep. I think. Yep. It's your smartphone?
Yes. The question was actually from me about the versioning. For example, no, I was thinking that like in GitHub, when you register for a certain software repository, that you just get an email about an update, for example.
Yeah. I'm not aware of that feature in Knowledge Junction. Is this possible?
Not that I'm aware of either.
No.
Of course, I mean, we can make, I guess that somebody in EFSA could be warned by the knowledge, and then you can make a system, of course, that there's so but I don't think it's directly possible.
So, yeah, so I just put it for those online. So it's a feature that is not available now in the Knowledge Junction, but it's for sure a good idea. Yeah. Are there further questions? Please use the mic. Yeah.
Thomas Pross from Bayer. One question more a little bit to the EFSA strategy. Will it then be also impossible in future for the applicants to use it for application of models in the risk assessment? So currently we are using models in the risk assessment, and then we are making PDF reports which we send to the authorities. Can that change in future?
This is not directly linked to RACIP, but we have a platform which is called R4EU, which is also linked with the Knowledge Junction, and their specific applications, which, for example, are linked with guidance documents that need to be followed, are available as tools which can run in a browser. So there are, and there we put the end products which are linked with guidance documents, which are linked with a specific mandate. And these are accessible for everybody. You just have to log in and put your name, and that's it.
But if I get the question right, you assumed, or the question was whether you can ship a FSK file to EFSA.
Exactly. Yeah, exactly.
And they will accept it instead of a PDF.
Yeah, because the EFSA models it's EFSA own implementations in R, but if you have more complex models, that does not work.
It's an interesting question. I will come back on this. Yeah.
So you just gave us another idea for new funding from EFSA. So thanks for that. Yep, over there.
Yeah, Ralf Eiser from BSF. I have a question. To what extent can you fill up your repository? Is it on nomination, or will you also do a search and browse amongst EU institutions? For instance, I know of many tools that are hosted currently by the JRC. You mentioned the BFR sources, the EFSA ones. Is it by nomination that I say there is something interesting, I could bring it to your attention, or is there also maybe a systematic search and browse from your end to harvest what is at least within EU institutions and national risk assessment bodies?
Yeah, so no, we don't search for resources currently because of our limited resources. But of course, if we have projects running where we know people create models, then we ask them really to put those models directly in this format. So it's just a matter of resources. And again, it should not be underestimated the effort to convert an existing model into this format. So this can really take you from a day, if you are lucky, until several weeks. Yeah, so because certain constraints of this format are not so easy to accomplish if the code, for example, is not structured already in the right way. Okay, so then we have only 3 minutes left, and I know that people need to move to the next session. So I would say thank you again for joining us. Thanks to the speaker for their great presentations. And with that, if you are interested, get in touch with us and leave us as a message, and then we will follow up on you afterwards. So all the presentations will be available on the event website, and we are really invited to join us. Thank you very much.